Hi everyone, welcome to this video on lesson 18 of the Earth and Climate Scheme of Work. This one it's called Factors Affecting Global Warming, and essentially the purpose of this is to, I suppose, bring together everything that we've looked at in the carbon cycle. So if I return to my diagram of the carbon cycle that I've come back to every single lesson, and I would recommend you do the same as you teach this scheme of work, keep coming back to this diagram. And what we're going to do today is really focus in on the kind of interdependence of all these factors within the carbon cycle. So it's a bit like when you're teaching food webs in plants and ecosystems all the way back in year 7. And it's kind of like, okay, if you change the population of one animal, what happens to the populations of all the other animals? How are they all interconnected as a system? And that's kind of what we're doing here. We're saying if you change one element of what's going on in the carbon cycle, how does that affect the other elements? And ultimately, we need students to make this link between the concentration of carbon, especially carbon dioxide in the atmosphere, and the greenhouse effect and global temperatures. So I think the first part you can go through just an overview of the carbon cycle and as I've done there, and just kind of talk about this kind of idea of interdependence of all the different elements within it. And then it's worth just getting straight into the examples. So the first example in the slides relates to, essentially it says 200 years ago, or in the last 200 years, population growth, energy consumption have both shot up. Therefore, we've burnt a lot more fossil fuels. Explain why that has increased the rate of global warming. So what I would do, before I get onto the writing part, I would actually try and show students what's going on in terms of the carbon cycle. So I might say 200 years ago, I've now lost my ruler, 200 years ago, what does the world look like? Well, let's say the world looks something like this. It's pretty simple. So we've got lots of trees. Now, I'm not going to vary the number of trees here because obviously deforestation is a factor. What's really important here is that you just do things kind of generally one step at a time. So Christian Mott Anderson, in his book on biology teaching, he talks about variation theory. I can't remember the originators of that theory, but the point is, it's a bit like the scientific method. When we're teaching things to students, we change one thing at a time. So let me show you what that means. So what I might do is firstly draw the carbon cycle as it should be. So I'm going to draw 3 trees here, and I'm going to make sure that I'm going to stick with the 3 trees because I'm not talking about deforestation here. I'm talking about burning more fossil fuels. And let's imagine we've got a person like this, and it's 200 years ago. So maybe we could even I'm being ambitious here. I'm going to attempt to draw a horse with a person on top of it. So this is my version of a horse, like this, and there's a person on top of it. And you can emphasize to students that what does a person riding a horse look like? Something like that. You know, this is before cars. Life is a lot simpler. We don't have so many of these kind of huge factories and things like this. Although I suppose we did 200 years ago, maybe 250 years ago, but you take my point. This is what the world looks like. So we've got this balance between photosynthesis, which is happening here. So I'll put photosynthesis is removing carbon from the atmosphere. So I'll put CO2 decreases. And here, respiration, and maybe they've got, I don't know, someone's made a campfire or something. Let's draw something like this. But we've got respiration and combustion. And combustion, they lead to an increase in CO2. So I'll put CO2 increases. So there's the balance. Plants and trees taking it away, animals and humans and human activities like making fires increases it. I think I'm being a bit mean to the what era is that? The Georgians in the late 1700s and just pre-Victorians. I think they were a bit more advanced than I've given them credit for in my diagram, but this is not a history lesson, so hopefully students will take the point. So let's then do another diagram which says today. So let's try and show what's happening here. And the point that I wanted to stress earlier is that I'm just looking at what's happened over this side. It would be another diagram if I wanted to talk about deforestation, and in fact we'll see that in the third of the worked examples. So I'm going to draw my same 3 trees here, and say, well, we've still got trees, and they're still taking carbon out of the atmosphere. But what we've got now is we've got many more people. The idea that we want to get across to students there is that there's much more respiration, so many more people. We've now got cars. We've got lots of factories, so I'll do kind of factories looking like this. Or, yeah, pumping out CO2 and so on. Let me just move that down. So what we can do is say, okay, well, we've still got photosynthesis. I'll just abbreviate this, photosynthesis causing CO2 to decrease. You could also said, by the way, we need more people. Well, you know, more animals needed to feed people and so on. There's lots of different things we could say. But essentially, what we could say is, let's draw kind of 2 diagrams, maybe even 3 diagrams, 3 arrows to say increased respiration, I'll just abbreviate it here, plus combustion. So CO2 doesn't just increase, it's increasing a lot. And then I could maybe even add a final element to my diagram to say CO2 concentration overall increases. So we're using the carbon cycle to show what's going on in terms of carbon. And I think it's worth drawing a diagram like this. I mean, if you wanted to do a pre-drawn one, that's absolutely fine. You choose whatever works best for you. But it's worth breaking down that thinking process step by step in terms of the carbon cycle. Because what we want for students to really understand everything that we're talking about here, they need to be able to think in terms of those elements of the carbon cycle, and this is where the diagrams really help to break it down. Now, once you've done the diagram and explained why this is, okay, CO2 concentration increases, we then need to link that back to what we did in the previous lesson. So I've got that under here, all of this stuff to do with, well, if you've got more greenhouse gases in the atmosphere, more infrared is absorbed by the Earth, and so on. So what we're going to do is turn this into a scientific paragraph. So this is a really good opportunity to just, I mean, it's really useful for exams. It's a good way of answering explain questions in GCSE science papers. But we're actually just teaching them, we're teaching them to think deductively and say, well, okay, if I do this, then what would I expect to happen if my other premises hold true? And the way I like to do this, yeah, you may have, if those of you within GLT, you may have seen me do this already. But I often think about an overall cause and an overall effect. So the overall cause in the worked example number 1 in the slides is the fact that more fossil fuels have been burned. More fossil fuels burned. And the overall effect was rate of global warming. I'll just put rate of global warming for the sake of this video has increased. And when I'm modelling this to students, I would get them to think about that. They may get the overall cause and effect confused. So they may say, okay, the overall effect is more fossil fuels being burned. And it's worth just giving them the counterexample and saying, okay, so do you think that the rate of global warming increased and that meant we all burn more fossil fuels? They'll go, no, that's crazy. And it's really about them picking out which of these is coming first. The purpose of this is to say, well, this is how I'm going to start my paragraph with the overall cause. How I'm going to end it is with the rate of global warming increasing. And it just gives them a start point and an end point. And then the goal of good scientific writing is to explain these 2 observations. We're burning more fossil fuels, global temperatures increasing, in terms of these abstract models. And this is where they're going to be using all of these keywords that we've included in here. So what I'm going to do is start with my overall cause. And again, because we're explaining, we're talking causally. So I'm going to use phrases like if and then. So I'm going to say if more. In fact, I'm not actually. Usually I do that. This is a good example here. this is actually talking about something historic. So I might say more fossil fuels have been burned. It's not if, it's not hypothetical. This has actually happened. So more fossil fuels have been burned the last 200 years. Therefore, and again, I really want to highlight to students that that word therefore is doing a lot of work here. That, instead of if and then in this case, that is showing that I understand what scientific explanation is all about. It's about linking things in terms of cause and effect. So more fossil fuels have been burned in the last 200 years. It's hard to write while talking. Therefore, what do I want to say next? Well, if more fossil fuels have been burned, that's telling me because of this increased combustion, there's more carbon dioxide released into the atmosphere. So I might say, and this is why the diagram really helps you with constructing this paragraph. Therefore, more carbon dioxide, to be honest, it might be better to say carbon dioxide has been released into the atmosphere at a greater rate. But for the time being, this will be fine. More carbon dioxide, I'll abbreviate to CO2 going forward. More CO2 has been released. Full stop. Consequently, that's a really nice way of linking together ideas causally. So consequently, and this is where I might just say there's more greenhouse effect. I'm actually going to go through it and talk about it in full. So I might say, consequently, more infrared radiation is reflected back and absorbed by the Earth. This means that another really nice way of linking together ideas causally. Again, you can model this to students. So this means that, you might say as a result, thus. Yeah, there's lots of nice ways of doing this. And this means that global temperatures, as a result, might have been better here actually, but global temperatures have increased. And essentially, I mean, this is maybe not a perfect example, but I've kind of got to this point, the rate of global warming has increased. I think possibly here I should have said, rather than more carbon dioxide has been released, carbon dioxide has been released at a greater rate, therefore the greenhouse effect has happened at a greater rate, therefore the rate of global warming has increased. But essentially, I've moved from more fossil fuels being burned, the overall cause, to global temperatures increasing, which was my overall effect. And again, I'm going to really highlight the way that I've linked together my ideas. This is what makes for fluent scientific explanation. I've linked those ideas together in terms of this causal language, these causal connectives. So that's the first worked example. You'll be pleased to know I've got the Blue Peter, here's one I prepared earlier for the second two examples. So for the second worked example, this one is about switching from fossil fuels to renewable. So again, what I've done is start with, if I just move my visualizer, start with the base case. So this is what it looks like at the moment. And then move to the case where we change something up. In this case, I've tried to show, here is my knocked down power station. I've replaced it with solar panels and a wind turbine. Again, I've kept the number of trees the same, so I'm showing that that part of the carbon cycle is still carrying on as normal in this example. But the point is, you've changed from having the arrow up here, the combustion releasing CO2. You've lost your arrow this time, and I've added a note here to say less CO2 released. Therefore, the overall effect is, well, the effect of that is the carbon dioxide concentration decreases. If I then turn to the academic writing, so the overall cause and effect are here. And again, what I can do is highlight to students where I've used these kind of causal connectives. So I've got if and then here. So that's a really nice way of doing it. And again, you'll see the same old favourites. Consequently, this means that, as a result, therefore, and I'll make sure that there's a copy of this paragraph in the slides for you to have a look at, but this is what you want to model to students. This one you might co-construct as a we do, for example. And then for the final one, this is a more complicated one, the final example, works example number 3, and I've done that deliberately. So this, the way I would explain this is by breaking it down into 2 parts, because essentially it talks about in Brazil, and again, you can talk about, you know, next time they go to McDonald's or something like that and they're having their cheap beef burgers, well, there is a cost to that in terms of the climate. So this is the normal case I put here. So if I just zoom in on that. So the normal case, we've got this nice balance. I've mentioned the methane here as well, so it's a nice opportunity to bring in a second greenhouse gas, and the carbon dioxide, so it's all from respiration and combustion, as we've seen. What happens if first you change one thing, the deforestation? So you've still got the carbon dioxide and the CH4 being released, but now you've lost that way of removing carbon dioxide from the atmosphere because you've cut down the trees. But I'm just changing one thing, and then I'm going to show them the second part of this, which is to say, well, okay, what if you then stick cattle on that deforested land? Well, then you've got extra carbon dioxide and methane being released into the atmosphere via respiration. Hence, the carbon dioxide and methane concentration increase even more. So you've lost the sink in step 1, and you've added more emitters in step 2. And essentially, you know, that could even be 2 paragraphs, which I've modeled over here. And again, these will be included in the slides, so I won't spend ages on these. But the first one is to do with deforestation, and then we can explain that in terms of there are fewer trees absorbing carbon dioxide for photosynthesis. The second one is to do with the increased farming of cattle, and again, because there's more emitters, therefore the rate of climate change or global warming. So that's how I would model this stuff. And again, you might, by this point, you're probably getting students to work on whiteboards and so on. Again, you may wish to have prepared diagrams before the lesson rather than drawing this live, because actually we want the focus to be on students doing lots of writing in this lesson. And I think the final thing to say is it's always worth going back to the students' lives. So not just finishing in this kind of relatively abstract sphere where all we're thinking about is moving objects around in our little carbon cycle diagram and adding different things to it. It's saying, well, what about the choices you make in your life? What about when you go on a foreign holiday and you take an aeroplane? What about when you eat a beef burger, especially from McDonald's or somewhere like that? All of these things, really getting them to reflect in terms of these new concepts that they have, getting them to reflect on exactly how that affects the world we live in and the atmosphere above us. That's how I think we can get students to really build some meaningful knowledge that is going to be helpful for them as citizens in the future, especially in this century where climate change is such an issue. Anyway, that is this lesson. I think it's a really important lesson. I apologize that this was a long video. I hope your students do some really good thinking in this lesson, and in the next lesson it will be a very brief video because it's just a review of everything that they've covered in this sequence.